Hi guys, it's Mr. T here, still hanging out at the beach, my pretend beach anyway. And this video, we're going to be doing a review of graphing linear equations. Hope it's going to be helpful to us as we get the rust off, getting started back in for this new year of school. So let me jump to our next page. Now I'm just going to go through several things along the way, a couple different examples of each thing. So, but before we do that, we got our coordinate plane here, and I've got set up by twos. Okay, we got two different forms. We got the standard form, which has the x and the y on one side and the constant on the other. So that's the standard form there. And a standard form doesn't. You want a positive out front generally, and no fractions, and you have to, on this side anyway. Then on slope intercept form, it's set equal to y, or the y equals form. And then on the other side, you have mx plus b, m standing for the slope. And we should recognize slope as being, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So basically, you subtract your y's over you subtract your x's. And then, or you could look at it as rise over run. It's funny because so many things in algebra are alphabetical, right? So when you have an ordered pair, it's x, then y. Well, when you put y over x, it's not alphabetical anymore. So they fixed that problem. Now we have rise over run. Now we're back to alphabetical. Helps you remember that a little better. Okay, so the m is the slope. The x is not the slope, just the m. And then the b, whatever the constant number is, it's called the y-intercept. That means where the line's going to cross the y-axis. Okay, and just in case we weren't so sure what those are, let's remind ourselves, this is our x-axis, and this is the y-axis. X's go left and right, y goes up and down, domain, range. Okay, so let's go in here, look at our first example here. First example here, we have in standard form, it says find the x and y intercepts. Okay, right, so kind of rusty on this, remember here. Well, let's remember, that means where it crosses the x or y, x and y axis, is it not? Yeah, that's where it crosses. Well, let's think about that. Every point on the, so this, what is this point right here? That is 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0. Catching on to a pattern? Yeah. Anytime that a line crosses the x-axis, what do we know for a fact is going to happen? That means y is going to equal 0. Okay, so what we can do is we can plug a 0 in for y, and whatever the x turns out to be is where it's going to cross the x-axis. Well, is that true for y as well? Yeah, that's the same thing. It's going to be 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So you could plug in a 0 for the x and find the y-intercept. Now, you can remember which one's which, and that's a good thing to do. And if you practice a little bit, you'll probably remember. The thing I want you to remember is to find the x or y intercept, plug in 0 into one of the variables. And if you pick the wrong one, you'll figure it out pretty quick, okay? Because when you get, after you plug in a 0 to one of the variables, you're going to get, if I plug a 0 into x, I'm going to get y equals a number. Well, that's the y-intercept. If I was looking for the x-intercept, do the other one. It's no big deal. It doesn't take that long to do it. So the thing I want you to remember is this. When it crosses the axis, one of the variables has to be 0, okay? And if you remember which one, bonus, you get that great. But either way, just start plugging in 0 for one of the variables, and if you pick the right one, then you only have to do it once. If you didn't, you got to do it twice. Big deal. It's not that big deal. Just plug in 0, you'll find an intercept to one of those axes. So I'm just going to take the first one that comes up here. I'm going to say 6. That's not really the color I was shooting for. I'm going to leave it here. 6 plus 4y equals -4. So I'm going to take the x out and plug a 0 in its place. And 0 times 6 is just plain 0. So that leaves me with 4y equals -4. I'm going to divide. I want to get y by itself, so this 4's got to go. So I got to divide by 4. And when I do to one side, I do to the other. And so I got y equals -1. So what is that? That is the y-intercept. You know how I know it's the y-intercept? Because it says y. It's not that, it's not crazy, So let's start all over. Okay. And this goes 6x plus 4. And this time I'm going to put parentheses right there around that y, because this time I'm going to put a 0 over there. So let me grab my eraser. I'm going to literally take out my y, and I'm going to put a 0 in for the other variable, which is y in this case. So 4 times 0 is 0. So that quickly gets us down to 6x equals negative 4. Okay, get x by itself. We're going to divide by 6 on both sides. Well, that's lovely. So what's 4 over 6? Well, that's 2/3. So it's going to be negative 2/3. Okay, and that's all well and good. And we would call that the x-intercept, right? All right. Now, could I use this information to graph this line? Well, certainly I could. Certainly could. So let me go over to y equals negative 1. So y equals negative 1 right there. So that means this line is going to cross right there. Okay. And then x equals negative 2/3. So there's 1. So there's about 2/3. Oh, they're right, really close together. So in theory, go change to my line tool. Okay. I could use this. I'm going to start here and go through that dot right there. Okay. And maybe I can, whoops, hit the wrong button. Here we go. Maybe I can stretch this thing. Should look something like that. So you can graph with the x and y intercepts. 2 points is all you really need, but I really like to have more than 2 points. So this is an okay way to do it. And it's a real quick, easy way to check some things as well. But this is standard form, find the x and y intercepts and graphing per se. Usually like to do it in the y equals, and we'll get to that in a minute. Let's do one more example with this topic in mind, okay? Let's go to our next page here. Here's another example. I'll slide through it again. Again, if it crosses the x or y axis, one of our variables has to be 0. So I don't get all crazy and uptight over which is which. Okay, I just start plugging in 0. And when I get to the other end, it's going to tell me which intercept I found, because it's going to say x equals or y equals. If you do several of these, you kind of get in the hang of it, and you don't have to, you can be more strategic about it. So I'm going to put my 0 right here. Now, what some people do, okay, a little trick you can do is, knowing that it's going to go away, what they'll do is they take your pencil or your finger and just put it right over the 5x, because you know it's going away. And so if I put my finger over the yx, can I do that figuratively? Yeah, let me do that figuratively. I'm going to put my finger over the 5x. So now, because we know the x part's going to go away, so basically I'm just going to divide both sides by -3. True? Okay. And then for the other one, they would say, well, just put your finger, and I'm putting a little box because I can't show you my finger, over the other one, and then now you're just going to divide both sides by -5. So it's a kind of a little trick that you can use there. Okay. I'm just going to go ahead and do the whole process real quick, because that doesn't take very long either. All right, so we got -3y equals 15. I'm going to divide both sides by -3. Okay. And this is, I'm getting in a hurry, so this is a spot that I might could mess up. And I don't have anybody watching me going like, Mr. Jake, you did that wrong. So I'm trying to be careful here. Yeah, that's right. So that's my y-intercept. And go start right over. Can't pick up where you left off. Okay. -5x minus 3y equals 15. So I'm going to erase my y and plug in a 0 over here for my y. So that guy goes away. And so it leaves me with negative 5x equals 15. Trying to get x by itself, so we're going to divide by negative 5. And so get x equals negative 3. Well, there you go. And so that's our y-intercept and our x-intercept. And I can graph those. So I'll go to my y-axis to negative 5, my x-axis to negative 3, and see, and then I can do a bad job of connecting these. Much better with the straight edge, isn't it? Oh my goodness, that is absolutely terrible. Okay, so that's fine. The x and y intercepts, and it can help you actually graph using the x. It's a real quick way to do that. Real quick, if you already have, if you're trying to find the one that it matches, it's a really good way. So if you have like 4 choices, this is a real fast way to check which one it is. Now that's one thing in dealing with standard form when it's got the x and y on the one side. So let's do a couple examples when it isn't like that, okay? So we're going to go back and take these same 2 problems and approach it in a little different way. Okay, this time it's going to say solve for y. And that's going to be super important for y'all because that's what your calculator does. You can't, everything in your graphing calculator starts with y equals. So solving for y is a big deal. Then we're going to identify the parts and then actually do the graph. So we're going to solve for y. That means 6, the x, and the 4 all have to go away. Okay. So the 6, the x, and the 4, all of those have to go away, and the y gets to stay. Okay. So the y gets to stay. The other things go away. So we're going to get rid of the 6x first. Now the temptation is for some folks is to divide off the 6. Well, if you multiply and divide, what's the rule? All the way through. That means you would have to divide this one by 6 too. That is not the case. So if you'll stick with those rules, I'm telling you, it'll help keep from some of these mistakes being made. So what we're going to do is this is a term. So we're going to subtract 6x on the left-hand side. So 6x minus 6x, that's 0. Good, gone. What we do to one side, we do to the other. And look what I'm going to do here. Did I even put it underneath the 4? Did not even put it underneath it because why? Not like terms. Big stuff number 2, right? So I've already used big stuff numbers on 1, 2, and 3 in the first few seconds of this to help me get on the right track. All right, so 6x minus 6, is that 0? Yes, it is. Okay, bring down my 4y. Okay, are these like terms? No, they're not like terms. But that doesn't keep them from being friends, does it? No, they can still be friends. So I'm going to say they can just hang out right next to each other. They just got to socially distance, you see, and put a little negative there between them. See, there you go. They can still be friends, but they're not like terms. You can't put them together. Just saying. Just saying. Okay. All right. So we almost got the y by itself. Now what we're going to do to get so this is 4 times y. So we do want to actually separate those, right? Where we took the 6x together. Now we got to divide everything by 4. Multiply and divide all the way through. Okay. So does this reduce to 1? Sure does. It's y equals, what's 6 over 4 reduced to? That's going to be negative 3 over 2. Okay, x, and then negative 4 over 4 give me negative 1. So what's the next thing? It says ID the parts. ID the parts. Well, this right here, that's m. Okay, so m equals negative 3 over 2, also known as slope. Okay, what's this guy over here? Negative 1. You notice I did not circle the x in this because mx plus b, the m is the slope, the x is the x. So what's this negative 1 run around doing? Oh, that's the b, okay? So b equals negative 1, also known as the y-intercept, okay? Now, one way to graph this would be is if we just put a whole bunch of numbers in for x and figured out what the y's were, and then we could plot a bunch of points and connect the dots, which is a great thing to do if it wasn't a line, okay? some of these other more complicated shapes, that's kind of how you have to do it. You just got to keep putting in points so you get your graph looking the way it's supposed to. But with a line, what we generally do, a much easier choice would be, let's go to the y-axis at -1 and put a little dot. That's our starting position. Get your engines ready, okay, at the starting line kind of thing. And then what's this guy here? This is our slope. And I think we've already talked about this. This is rise over run, okay? So what I always like to do is I like to always rise and then run left or right. Always rise, then run left or right, according to what the sign is. So I'm going to go up 3, 1, 2, 3, and then I'm going to run to the right or to the left. To the left. Okay. Now let's think about what we've done here. -3/2. Is that going uphill or downhill? Negative makes it go downhill, right? So from left to right, are these two dots going downhill? Well, they certainly are. Okay, so I'm going to continue the pattern. So I'm going to go up 3, 1, 2, 3, left 2, 1, 2, 3, 1, 2. And once you get the pattern going, you should be able to go through it pretty quickly. And then I can turn this over to my line and get a pretty good line. Oh, let's go to red. Dot points first, line second. What came first? Points, then the line. You don't sketch it and then put points. That's sketching, not graphing. So easy peasy right there. Bam. We graphed our line. So we solved for y, ID'd our parts, and then did the graph. Let's start over. Let's do the other example that we did earlier. Okay. Right. Let's get over here to. It says solve for y. So that means -5x and -3 got to go away. Y is going to stay around. So I'm going to add. I want the 5x to go away. So I'm going to add 5x. Okay. What I do to one side of the equal sign, I must do to the other. And again, this is a strong technique I want you to suggest you use. Don't write that underneath the 15. You might accidentally add unlike terms. And we're not supposed to do that. So be safe and don't even put it underneath it. Okay. Separate them automatically so that you don't make that crazy mistake of adding unlike terms. Okay. Just say it. All right. So does this cancel? Well, it sure does. So, okay. That does cancel. So that leaves me with -3y equals. Now I'm going to bring the x first. And then add my 15 after that. So we almost got y by itself. Not quite. So here we go. We're going to divide -3 to get rid of that -3. So do I do it to the x or the 15th, or do I do it both of them? Both of them, right? Because we multiply and divide what? All the way through. Maybe I'm starting to convince you how big those first three big stuff is. Big deal. Saves you a lot of trouble from going down the wrong path. All right, so this reduces to 1, so we got y equals -5/3x, and positive 15 divided by -3, that'd be -5. Said to ID our parts, right? So here we go. We're going to say that m, also known as slope, is -5/3. I'm going to write slope, just so we're very clear. And then I'm going to say b is equal to 5 or -5. Well, the negative goes with this, doesn't it? So it's going to be -5, and that would be our y-intercept. Okay, so we go graph this. Yeah, we're going to go down on our y-axis. You know, this is our y-axis. There's your x over there. So go down -5, which is between 4 and 6, right? All right, now we're going to do our slope. Okay, go rise over run. 1, 2, 3, 4, 5. Now, if I go to the right 3, is that going to be a positive slope or a negative slope? It's going to go uphill from left to right. So that's positive slope. We don't want that. We want to go left 3. And I always suggest go up first and then go left if it's negative, right if it's positive. Even if that pops you off the top of your graph, you can always reverse it back down. Just through experience, people usually, if they go up, they'll remember to go left or right easier than if they go down. But that doesn't mean that you can't go down and then go to the right and still accomplish the same thing. That is fine. I'm just saying more people get it right more often if you do it in that order. Um, we all have human error. We're just trying to find ways to reduce our human error. 3, 4, 5, 3, 3, 4, 5, 3, 3, 4, 5, 3. Okay, that's a bunch of points there. Now I can draw an accurate graph and not just a sketch. And it didn't take me but just a second to do so. He was like, oh, good grief, that takes forever to do that. Well, it didn't take forever to count a few things off. Not that big a deal. The more points you have, the more accurate, even if you don't have a straight edge, the more accurate you can draw your line, isn't it? Okay, so solve for y, identify our pieces, and do the graph. Okay, I'm going to switch gears in this graphing thing to talk about some special cases. Okay, special cases, and this is always something that kind of throws people off because when I see y equals -3, I just see that's a number, right? But why is y equals -3 in this situation going to be a graph of a line? Well, let me give you a hint. It says graph the equation. It's context, folks. It's context. If you're in a situation where you're talking about graphing, it's a good chance it's a graph of a straight line. And when it's y equals or x equals, it's either going to be a horizontal line or a vertical line. Horizontal line or a vertical line. And I used to get all upset and frustrated with that idea. Which one's which? Well, here's the deal. Watch this. Okay. So this is y equals -3. Can you find where y equals -3 on the graph? Well, you sure can right there. Put your little dot. Now, what do you think? Should I draw a vertical line or a horizontal line through that point? Well, there's actually an occasion we could do a vertical, but it would feel so weird and awkward. It would make way more sense to you if we drew a horizontal line. There you go. You just fixed your problem. Put you a dot on the axis where it belongs, and then draw a vertical or horizontal line. And it will come natural to you which one to do. The only time that that really changes is if that's y or x equals 0. And then it's just the axis, and then that becomes a little weird. But almost always that's going to get the job done for you. Let me change this over. And let's draw us a nice blue line, horizontal line. Now, how can I check to make sure I've done that right? It's a little bit low. We'll just have to live with that. So this is what? 0, -2, -3, excuse me. 1, -3, 2, -3, 3, -3, 4, -3, 5, -3, 6, -3. Catching the pattern? This is a line where y will always be -3, correct? X is going to be different things, but y will never change. It's constant, thus known as a constant. That's why it's constant. This will not ever change. Okay, y's will always be -3. X's will change. So we're not even paying attention to the x's in this case. Okay, well, let's go back to this other guy here and give him a shot. How about x equals 2? Again, I use that same philosophy here. This is the x-axis. I'm going to put a dot on the 2. It would feel weird to draw a horizontal line through the dot, wouldn't it? Yeah, it just wouldn't feel right. So that's going to cover most of your troubles right there. Okay, put your dot on the correct axis and draw your line through it. Well, it's pretty terrible. That's not too bad. So, and then pick some points on the line and see if it actually is a true statement. So is this point right here x equals 2? So if I go over 2 up 3, yeah, the x is equal to 2. Every point on that line, x is going to equal 2. So that's how you do the horizontal and vertical lines with just a single variable next to it. Feels kind of odd, but it's actually easier but it ends up being so easy that you try to make it hard and you're overthinking it. All right. Well, I done hit the wrong button again, but we're going to get back where we need to be. There we go. Now, got a couple of things out here I threw at you just to see what you would do at the very end, because these aren't lines. They are not lines. And here's my point. What you're going to do with these things is how you handle everything. At the worst case scenario, on the worst case scenario, you can always just plot points. And people ask me how many points you want for different kind of graphs. I say plot enough points so it looks like it's supposed to. And usually fill up what you have there in the middle. Okay. So fill up that space that you have there. And now if you're doing a whole bunch of points on a parabola and you keep on going to just one side of the parabola, you might want to go the other direction, plugging in numbers so you get the other side of the parabola. That's what I mean. Keep plugging in points till it looks like it's supposed to. And if it doesn't seem like it's making any curves, you should go maybe put points from the other side. Try that, until you get what you need. So for this, just a real rough kind of way we could do this. It's kind of the long way to do it. We got without a calculator, and I'll show you the work with this calculator in just a moment. So what does this mean? So what do you say? Let's plug in a 1. A 1 right there. So that's going to be -5 to the 4th power there. Oh my goodness. And then 3 times something to the 3rd power plus 1. And what did I say? Let's plug a 1 in for both of those. Okay, so 1 to the 4th is 1. 1 times -5. Well, that's just -5, isn't it? 1 to the 3rd power is still 1. 1 times 1 times 1. And then 1 times 3 is 3. So that's plus 3. And then plus 1. So -5 plus 3 plus 1, that's going to be equal to -1. So there's my first point, -1. 1, -1. So I'm going to go over 1, down 1. There's my first point. Okay, now I'm going to plug in a 0. I just like plugging in 0. Just makes things, I like to use a positive, a 0, and a negative. That's how I kind of get started on things and just see what happens from there. Okay, so start again. So now we have -5 to the 4th plus 3 to the 3rd there plus 1. I'm going to plug in our 0. So that turns into 0, that turns into 0, and that whole thing turns into 1. So there's another point we can graph. 0 left and right, up 1. There you are. So, all right, let's try -1. So let me do that. -1. Oops. Well, that's fine. We'll stay with it. So -1 times -1 times -1 times -1 is +1. And then that turns into 1 times -5. Okay. This is to the 3rd power. So -1 times -1 is +1. And then +1 times -1 is -1. So -1 times 3, oops, that's -3. And then bring down the +1. So it's -8 plus 1 gives me -7. So that's -7. So let's graph that. So -1, -7. That's a very, very interesting graph. Okay. Give me just a second here, and I'm going to show you a couple more little tricks how to manage this. Okay, finally got my calculator up. So what we're going to do is I'm going to take this original equation, slide it into my calculator. So here's my calculator. I'm going to hit the y equals button. That gives me my graphing pieces. And we had a -5. X is next to the alpha key there. Some people hit alpha, whatever. Just no, right next to alpha is the X button. Just hit the X button. Now that needs to be to the 4th power. So I'm going to go above the division sign where that rooftop is. It's got a caret. and that's what its official name is. And there's a hit 4. And now I need to hit the right arrow or everything's going to be an exponent, okay? And then we're going to do a plus 3x to the third, right arrow to pop out of the exponent, and then plus 1. Plus 1. And I'm going to hit zoom. I'm going to say hit the graph button. No, zoom before you graph. What did I say? Zoom before you graph. Because what I want you to do is I want you to reset to your standard window. See at 6, zoom standard, okay? Because who knows what was happening before. You could have been doing any kind of crazy stuff. And so that's kind of what we're looking at there. Now I want to take a closer look. So I'm going to hit zoom, and we'll do more of this later. So if I'm too fast with this, zoom in, and you see I got a little crosshairs here. So I'm going to hit enter one more time. So it's actually going to zoom in. Well, look at that. That's a kind of an odd shaped little dude. Okay. So that's what I mean. You're going to keep doing some points to figure out what is going on with that. So let's come back over here and see what we got. So, wow. So to get the rest of that, we would have to do a whole lot of decimals in there. Because see, there's 1 and there's -1, and there's the point that we did. So for right now, I'm just going to fake it, tell you the truth. Is that okay? Can I be truthful with you? Will you allow me to do that? For our purposes at the moment, this is going to be good enough. Not always, but this case it is. So we said it went kind of up and then, oh, this is terrible. And then kind of dipped and then up and then, oh, that's a really terrible graph. But that's really about all I could do with those 3 points. But what if I could do more points? Let me go back over here. What if I could get to more points? How could I see more ordered pairs? Well, on our graphing calculator, what I'm going to do is I'm going to hit second graph, and it's going to give me all the ordered pairs I could ever want right there. Just go up, and it's going to keep on going. Now, I don't suggest trying to do the negative 44,991, but you could get all those if you needed to, okay? So let's come back down here, and I would probably stick with the ones that I could reach, which would be the 3 that we've already done, okay? So that's the idea. You just plug in point numbers, get some points, plot points until you get the best you can, and go from there. We'll do more with that later. But that's just kind of a fun sidetrack since we're really just doing lines. Okay. And then here's another guy here. I'm going to show you another little trick on this. And again, you're not going to remember all the details with this, but I'm just kind of planting a seed for later. Okay. So again, we could plug in a number here and do the order of operations and get a bunch of Y's. Absolutely could. But check this out. This is to the second power. It's going to be a parabola. I already know that because it's the second power. And I already can tell you where the vertex is going to be. I can. The vertex is going to be at +5, 3 for our parabola. Sure is. It's going to be over 5 up 3. Okay. And then it's going to open down. I'm even going to tell you that it's opening down. Now, that's just to give you an idea of what's going to happen there. But you'd have to plot points to get all the rest of it, just to give you an idea. So that's going to point you in the right direction for those guys. All right, and just to prove it, so it's -2/3. Okay, so let's come back over here. Clear that. So that is that here. Okay. A little too big. Okay. So negative alpha y equal, bring in my fraction. We said that was 2 down 3 right arrow to get out of there. So we got open, x next to the alpha key, minus 5, close. And this time I can just come over here, catty corner to the 7, and hit the x squared. So it's actually got a square. Now cubes and other things, you got to use your little caret rooftop thing. And then I believe the next piece was +3. Let me double check that. Yes, it was. And then now I can hit zoom. See, now I zoomed in before. I want to hit zoom 6, zoom standard, resets my window. And then there's my parabola. And where's the vertex? over 5, up 3, just like I promised. So if you don't get all the piece, all the details there, that is fine. One other piece I just really want to make sure that you're following with when you get to your worksheet. Um, most of the graphs that you have on the worksheet ha- have two different things that need to be graphed on it to save space on the paper. We just did that, just trying to think economically there. And so you're going to have probably a problem before the coordinate plane, and a problem after it. All right, so be careful. Almost every one of those, I think every one of those should have two different things on it. Okay, so just like my graph here that had two different graphs on it, your homework should look similar to that too. You should have one line for one number and one line for the other. Just label which one's which. Be careful with that. So let me get back here to the very beginning real quick. So a little quick review of linear equations in standard form and the slope-intercept form, also known as the y equals form. The thing next to x being the slope and the b being the y-intercept. Hope that's helpful to get the rust off, and so you can do some good graphing of linear functions.